In problem number 1, both terms share the same radical. You need to add the coefficients, which equals 6. Then the answer is 6 cubed root of 3.
Problem number 2, you have two different numbers under the radical, and if you want to add the coefficients, you need to have the same one. So what you have to do, you have to divide 352 by 11 to get both of them to be 11. So once you divide that by 11, you get 32 and 11. Now, they're still inside of the radical, so right now you have fifth root of 32 times 11. 32 is a perfect fifth, which is 2. So right now you have 11 times 2 times radical, well, fifth root of 11, plus 7 fifth root of 11. 11 times 2 is 22. Now you have the same number under the radical, so you can just add the coefficients, which equaled 29 fifth root of 11. That is your answer.
Problem number 3, you have to take the fourth root of every number and variable. So first you take the fourth root of 81, which equals 3. Then you take the fourth root of W16, which equals W4. Then you take the fourth root of M8, which equals M to the second. Then you combine all answers to get 3W to the fourth, M to the 2.
In problem number 4, you want to take the square root of every number and variable, and whatever is left over you want to keep it. And whatever you take out comes out of the radical, and whatever is left over stays in. So first you want to take the square root of 121, which comes out to 11. Then you want to take the square root of M5, and how you do that is you divide the power by 2 because the problem is squared, which comes out to be m squared with a leftover m. So it's m squared radical m. Then the next one, it comes out evenly. Radical n to the 10th power equals n to the 5th. And then the next one, you have 1 left over. So radical p to the 3rd comes out to be p radical p. And once you combine all the numbers and variables outside the radical and the ones in, you get 11 m squared n to the 5th p radical mp.
Problem 5, you have to multiply the powers, which is 4 times 1 over 6, which equals 4/6. That simplifies to 2/3, so you take the 10 out, the answer is 10 2/3.
In problem number 6, you have to subtract the powers. So here you have 14 over 14 to the 1 over 8. 14 has the power of 1, so when you subtract the powers, you do 1 minus 1 over 8. To make it easier, you can just give them a common denominator. So 1 equals 8 over 8. So you have 8 over 8 minus 1 over 8 equals 7 over 8, which comes out to equal 14 7 over 8.
Number 7, you have to multiply numbers in the radical, which is 2 times 108. 2 times 108 equals 216, which is a perfect cubed root, which equals 6. And that's your answer.
Problem number 8, you have two radicals being divided by each other. Now, in this specific problem, you're able to divide 486 by 6. So you take them out of the radical and you divide them. This comes out to be 81. Now, after you divide them, you have to put them back into the fourth root, which comes out to be 3.
In problem number 9, you have to multiply the denominator by a number to get a perfect fifth root. The perfect fifth root of 81 is 243. To get that, you have to multiply the fifth root of 81 by the fifth root of 3. And then whatever you do to the bottom, you have to do to the top. Once you multiply straight across, you get fifth root of 6 over fifth root of 243. And since the fifth root of 243 is a perfect fifth, that comes out to 3.
Problem number 10, you have 5 over 3 plus radical 5. Now what you have to do, you need to get the radical off the bottom. And to do that, you need to multiply both sides, top and bottom, by the reciprocal of the denominator, which is 3 minus radical 5. Now once you multiply across, you get on the top 15 minus 5 radical 5 over 9 minus 3 radical 5 plus 3 radical 5 minus radical 25. The minus 3 radical 5 and the plus 3 radical 5 cancel out, so you're left with 9 minus the square root of 5, which the square root of 5 is 5, so you have 9 minus 5. Now that goes to 4, you get 15 minus 5 radical 5 over 4.